For my feelings, does anybody ever go back and look at the videos or anything? No? Okay. Just know they're there if you ever need to go back and look at them. So on page 84, we have an area model. We have an area model beside it. Are there any values of x that would make that equation true, that quantity x plus 2 and quantity times quantity y plus 2 and quantity equals xy plus 4? Xy plus 4. Are there any values of x that make that equation true? I need to think about this myself. What do you think? Quantity x plus 2 times quantity y plus 2 is equal to xy plus 4. Xy plus 4. So let's take a look at, well, before I say that, what do you think? Yes? No? Is it always true? Sometimes true? Never true? Who said no? Why do you say no? It is Demarian, right? Okay. Yeah? Okay. It doesn't equal it. Why not? You don't get that answer. Is there something missing or something that has been added that shouldn't be? Okay. Is there something extra or something missing? There's extra? Okay. Do you want to tell me what you think the extra is, or not sure? You got to redo it. Okay. What about anybody else? How would we go through and begin to solve this? What should you do with that left-hand side of the equation? By the way, what makes this an equation? The equal sign. And what never has an equation in it? Expressions. So they are very different. Equations always have an equal sign. Expressions never have an equal sign. We simplify expressions, but we do what with equations? Solve. Okay? So how would I begin to solve this on the left-hand side? When you have a binomial times a binomial, so two-term times a two-term polynomial, what would you begin to do here? Yes, you're going to distribute, and when you distribute, you take first term times the first term, outside times outside. Have you ever heard of FOIL? Did I ever talk to you about FOIL? Not the aluminum kind, but first times first. That is the first term times the first term of the second binomial. The outside terms, so this is the outside times the outside. Then you take the inside two terms, so the 2 times the y, and finally the last terms of each binomial. Now, this only works for multiplying a binomial times a binomial, but it's called FOIL. A binomial times binomial. Okay? So when I do that, I get First times first gives me what? XY plus the outside, yes, x times 2 would be 2 times x. Inside would be 2 times your y. Those are the two inside amounts plus 2y. And then last times the last is 2 times 2, which is 4. So we're saying, is this equal to this? Well, if it were, we'd have to get rid of these two terms. What's the only way we could get rid of those two terms? What would x have to be? Not necessarily y. You don't have 2x over here on the right-hand side. So if I don't have it, that must mean it's the answer to 2x must be 0. It's not there. So what does x have to be? If 2x is equal to 0, x has to be 0, right? So if 2x is equal to 0, divide by 2, x has to be equal to 0. Same for 2y. There's no 2y over here. So if 2y, if there's nothing over there, then y also has to be 0. But if that's the case, then x times y here would have to also be 0. And so instead of saying just 4, the actual answer they gave us is that x times y plus 4 is equal to that. So is that ever going to be true? No. Because we should end up with all of these. If x is 0, y is 0, then this would be 0 too. We would have just said 4. So that means this is never true. Never true. So what they are showing us here with the area models, we've got x times y, this is xy, and we have 2 times 2, which is 4. We don't have these spaces at all, which means those must be 0. And if that's 0, then this y should have been 0, because this is y. And if this is 0, that means this x would have also been 0, but that would have zeroed this out too, but it's also there. So that is never going to be true. Why? Because if these were 0, this should have been a 0 also. Okay? So, next up, an identity. You guys took that little pre-file quiz the other day. An identity is, anybody have an idea? Starts with an and, so what does that mean that first letter must be? If you say and, that means it has to start with a vowel, right? So an identity is an, what are we talking about? In general, equations. So an identity is an equation that is blank true. What do you think? Always true. And the one that several of you did pick up is when you're using the distributive property. So when it said 2 times x plus 6, and they gave you 2x plus 12, some of you said, yeah, that's an identity, because what you get on the left-hand side is always going to give you something on the right-hand side. Or when it said 2 times x minus 3, and was that the same as 2x minus 3, you said, no, that's never true, because following distributive property, it didn't come out to be the same. It didn't follow. Okay? All right. questions about this? So this is never true, and an identity is an equation that is always true, following distributive property or some other properties. Okay? All right, now let's get to the fun part. So you're going to work with a partner. I am going to give you several of these pale yellow canary equations. They're all equations. You have to decide as a twosome if they are, I should look and see what order I put them in. I think let's go with, let's put always true as the first category, sometimes true, or never true. Okay? Working with your partner, decide if the equation is sometimes, never, or always. But let's do always. Starts with an A, so do that one as your first column. Sometimes, that's going to be in the middle, and never true. Okay? So you are physically going to put them on the table and try to put them in these three categories. All right? If you would like to use a whiteboard and some dry erase markers and the cloths, please feel free to do that also. Okay? All right.